Hello, quick video on linear regression and how we use it. We often have two variables and we want to work out how they're related, and we can typically draw a straight scatter diagram as you've got in the bottom left, and then we do a line of best fit by eye. What would be really useful though would be to have a tool that would do the line of best fit mathematically, and we can use a regression analysis to find our linear line of best fit, and we can use our correlation coefficients to look at how strongly they're correlated. So here's the formula for linear regression line. So we've got how far our y value is away from the mean, the y mean on the left, and we've got how far the x value is away from the x mean on the right, and then we've got a gradient made up of two factors here. The top one here is there's our cross product that we looked at in the correlation video, and there's our sum of squares of the x, which we've used in standard deviation in the past. So let's have a look at how this works, how we get that answer. Well, regression lines are often called least squares regression lines, and that's because what the maths does is it looks for the residues. This is here, see this line here, the residue is the distance of a particular point from our best fit line. It calculates all of those and squares them so that we've got a positive, and then adds them together, so we've got some of those residues, some of the squares of the residues, and then the maths looks to select a gradient and a constant to minimize the value of that. So in each one here, it's looking to minimize these residues, which is the y value, take away the mx plus c it's created. I'm not going to go into the detail of that in this video anymore. Okay, the result of that process of minimization is we get a standard formula in which we're going to use our sxy value and our sxx value calculated in the standard way. So let's have a go at this with our Premier League example we were using before. Here are, so we're looking at the connection between goals scored and points earned, and we're going to use the 2003 Premier League data to do it. So here we have Team A, the winners Arsenal, scored 73 goals, and as a result they earned 90 points, and the worst team were Wolves. They scored 38 goals and they got 33 points. So here we're interested in the fact that we think goals are driving points, so that's going to be our independent variable, our driving variable, and the points are the resultant or dependent variable. Okay, it's easy enough from this data to calculate what the mean is. So the mean number of goals was 50.6 and the mean number of points was 51.6. And we can calculate the sum of the cross products as 22,2266 goal points, and the sum of the squares of the goals is 1486 goals squared. Just to have a quick look from our spreadsheet, we can get these from our spreadsheet. We can put in at the top here, we've got our teams and how many goals and points they scored for each team. We've got the differences here. We then calculate in these two rows here, and then we calculate the product of those two, multiply them together to get our sxy. Here they are in that row there. So most of these are positive, aren't they? Fitting in with the fact that more goals scored here for the winners gets more points, and here less goals scored gets you less points. So if we adding up that whole row, we get 2266 goal points. And then if we look in this next row down here, we've got our goal differences squared. There we are, and they're all positive, aren't they? Because they're designed to be. That's our sum of squares of 1400 goals squared. Okay, so that's how we can use a spreadsheet to do it. We'll come on to look at a calculator in a sec. So if we put those values into the formula, we quickly get that y minus the mean number of points, 51.6, and on this side we've got x minus the mean number of goals, 50.6, as x is the driver, and we've got our two values here, the sxy value and the sxx, and when we multiply that out, we end up with a gradient here of 1.525. So for every extra goal you score, you get 1.5 points. That's roughly what it's telling us, isn't it? And then if we bring all our constants together onto this side by moving the 51.6 over, we're going to be able to work out our constant, and that's minus 25.5. So that says if you don't score any goals at all, you'd end up with minus 25.5 points, but that's well outside the scale range that we're working in. And if we did the calculation, we'd find the R value is the same as we had before, as 0.8886, which was strong positive, wasn't it? So let's graph these figures. Here are the values in the individual teams here, and all that on the bottom we got goals, and on the top we got points. So here's each team. So there's 20 points for the teams. Here's the line, the linear regression line that the spreadsheet is calculated for us, and we got very similar numbers here written out there. So y equals 1.5 times the x value minus the 25.5. You can see at the bottom also here we've got an r squared value. That's the value of our r that we saw earlier, 0.8886 squared. They tend to show that in spreadsheets. So we can see here that we've got a nice neat correlation, haven't we? We've got a positive correlation in that more goals scored equals more points, and it's quite neat and tight, isn't it? Only a few outliers, these ones here are a bit further away, but everything else is neat and tidily near the line. So that reconfirms that we've got positive, solid positive correlation here. Now the next thing we need to look at is we can get these out of our calculator. So let's whiz our calculator onto the screen. Excuse me, I'm just going to go back so we can see the graph at the same time. Okay, so here's our calculator. Remember, we put our values in. We put in list 1, we put our x, our goals, in the x column in effect, because that's what we think is the driver, and in the list 2 is going to be our resultant. That's the points we get as a result of that. And we can put those up and we could graph them. So that's what we did before. And we can press our calc button, and we're looking at a linear regression, so we're only interested in the single power of x. So there we are, and on our screen we get our linear regression. So here at the bottom we can see that it's calculated for us y equals ax plus b. So the a is our m and the b is our c, and y equals mx plus c. So the a is the gradient, and there's our 1.5246 there, and the b is our constant, that's our minus 25.5. And the next column down, row down rather, we've got our correlation coefficient of 0.8886. And if we click the draw here, we're going to get almost exactly the same diagram as we've got from our spreadsheet. There's our scatter of our points, and there's our linear regression line. Okay, only one other thing for us to look at now is the idea of how we can use this to interpret the data. So I'm just going to take those off so we can have a look at it. And what we've got is we can use this to predict values. This is called interpolation. Okay, so let's say that I predict that my team are going to score 60 goals next year. Well, I can feed my figures into the formula that we've got, and we can come up with a number of goals. So let's just do that by just whizzing down quickly to have a look. So for 60 goals with a gradient of 1.525 and a constant of 25.5, we would expect to get 66 goals. Okay, so that's basically what we've done mathematically. We found this point here, and that would be 66 goals. And we could do that anywhere within this range here of the actual data, and we would call that interpolation because it's internal to what we're working on. Okay, now we could also go to a more extreme, and we might want to predict how many goals how many points we get if we only scored 20 goals. Well, if we dotted the line on, we'd probably be somewhere around here, wouldn't we? Somewhere between 5 and 10 points you get for only scoring 20 goals. And if we had scored 80 goals, we'd probably be somewhere up around 100 points, wouldn't we? But we can't be certain of that because it's outside the range of our data, so we're taking a risk if we use any of that, and we would call this when we go outside the area, it's extrapolation. That's extra, that's external to. It's outside, yeah? So we could use that. So interpolation is pretty safe. You can see where the point would be. Extrapolation is not really very safe because you don't really know what the trend is if we go outside. Okay, here's our summary. Regression lines or linear regression lines, often called least squares. And here's the formula for a linear regression line. We would use our correlation coefficient if we needed to use that, and we can then use our regression lines to interpolate values in our range, or at risk we could extrapolate outside the range, but that would be a risky thing to do. Hope that's of use.